MAT 1033 review for test 3. In these first problems, we're going to factor completely. This problem, number 1, is 4 terms. Your clue for 4 terms is to try grouping. So we're going to make 2 groups and then look for a GCF in each group. So in the first group, 42 and 24 have a common factor of 6. Also for the variables, we have u in both. So we'll take that out. We'll make one set of parentheses, and then we're trying to just get back to that group. For our first term, we have a 6 with like a 42. So we're missing a 7. We have a u, that's what we want, and would like to get a v. We're missing the v, so we need a v here. For our second term, we have 6, we want a 24. So we're missing a factor of 4. We have the u outside, but we're missing the x. Then we'll go to the next group. Because it starts with a negative, that's a clue that you should take out a negative GCF. And we have a common factor of 5 with the numbers. For the variables, we can take an x. Then we'll make our parentheses. To get back there, we have negative 5, we want negative 35. You're missing a factor of 7. We have the x, we're missing a v. In the next term, we have negative 5, we want a negative 20. So we need a positive 4. Negative 5 times positive 4 gives negative 20. We have 1x, we want 2, so we need one more. Now we'll look at our whole term, and what we hope happened is that we did get a common binomial, which we did. So now this will be our GCF. So we'll take out the 7v plus 4x, and to get back just to the line above, we're missing 6u minus 5x. Problem 2 is also 4 terms, so we will try grouping, and we'll make one group and another group. Then we will look for a GCF. In the first group, 9 and 21, we have a common factor of 3. We also have an x. To get back there, to get 21, we're missing a factor of 7. We are also missing a y. For the second term, we need a 3. Go into the second group. 49 and 21 have a common factor of 7. We'll make our parentheses. To get back 49, we need a 7 and a y. To get back 21, we need a 3. Then we look at the whole problem, and we hope we were able to get a common binomial, which we did. That is now our GCF. So we can take out the 7y plus 3. And to get back just to the line above, we're missing 3x plus 7. Your order of these two parentheses does not really matter. If you have the 3x plus 7 first, that is okay. Problem 3 is 2 terms. Your choice for factoring 2 terms is to use sum or difference of cubes or to use difference of squares. You look at your exponent for a clue. When the exponent is 2, you should try squares. So if we have perfect squares, we are able to do it, and we do. We will use 2 sets of parentheses. One will have plus, one will have minus, and we'll use the square roots of the terms. So for 4a squared, we have 2a, and for 25b squared, we have 5b. This is the easiest kind of factoring that there is. Problem 4 is also 2 terms, but notice the exponent is a 3. So we will have to try cubes. And it's plus, so this will be a sum of cubes. If you can get cube roots, you can do it. For u cubed, the cube root is u. For 27, the cube root is 3. So we're going to be able to do it. The cube roots work with a nice pattern. You're going to use the roots for your first parentheses, with the sign of the problem. So we'll have u plus 3. Our second set of parentheses on a cube problem is a trinomial. It's the only one we've had like this. For your signs, the first sign in the trinomial is the opposite of the original. This is so that you'll get some canceling. So if that one was plus, this one has to be minus. It will always be the opposite. Your last sign in the trinomial is always plus. Then you'll go back and take all the combinations of multiplying the roots. So we're going to do first root times itself. That'll be the first spot. First root times the second root. That will be the second spot. Last root times itself. That will be the third spot. So first root times itself. U times u gives you u squared. First root times the second one. U times 3 is 3u. Last root times itself. 3 times 3 gives you a 9. This trinomial will not do more when it comes out of a cube. So you are done. Problem 5. This problem, if you look at it, it is a difference of squares. But what you should always try first is see if there is a GCF. If there is, you should do that step first. There actually is a GCF in this problem, so we will do that first. There is a common factor of 4. So we will take it out of both terms. When you do GCF, it's one set of parentheses. Right, to get back to the original, we're missing a 4a squared minus 1. Anytime you have something that's still to the second power or higher, you have to see if it will do more. So now we're looking at this parentheses, and it is squares again. So on our second step, we are going to do squares. The GCF just comes down. You don't do any more work on it. We'll ignore it, but we need it in the answer. And now we'll work on our second term. So we'll do difference of squares. One parenthesis with plus, one with minus, and do your square root. So for 4a squared, we'll do 2a, and the square root of 1 is 1. Problem 6 is two terms. So we look at the exponent, it is a 2. There is no GCF, so we are going to go ahead and do squares. We'll do our parentheses, different signs, and for your 4, we'll do a 2 and an R, and the square root of 25 is a 5. So it does work as difference of squares. Problem 7 is two terms, but it has an exponent of 3. So you have to try cubes. So we see if we can get a cube root. For 64, the cube root is 4 and an x. For 125, the cube root is 5 and a y. So we are going to be able to do cubes. So this one is a pattern. You use your roots with the sign of the problem. That makes your first set of parentheses. Your second set of parentheses on a cube is a trinomial. For your signs, the first sign is the opposite so that you get some canceling. The last sign is always plus. And then we will go back and take all the combinations of our roots. So first root times itself. 4x times 4x is 16x squared. Then we'll do the first root times the second one. 4x times 5y will give us 20xy. And the last root times itself. 5y times 5y gives us 25y squared. This trinomial will not factor more when it comes out of a cube problem. So you are done. I wanted just to rewrite it for you below so that you could see the entire answer since I was running out of space on the frame above. Thanks. Problem number 8 is a trinomial. It is not one of the nice ones because it has a coefficient on the leading term other than 1. So we'll go through our steps. You should always first try a GCF. There is no GCF. The second thing you should think about is whether it is a perfect square trinomial. This one looks like a good candidate for that, but it actually doesn't work. For perfect square trinomials, you need a square at the front, which we have, and you need a square at the end, which you have. And most of the time, the square roots will work. So we'll go ahead and try that. The issue is our signs. A negative at the end says you have to have different signs. That's the way you multiply to get a negative. Right? And we would use square roots for perfect square trinomial. So 3n and 3n. And for 16, we would do a 4. And then you have to check outside and inside to see if that works. So we have a minus 12n and a plus 12n. And they actually cancel, so there wouldn't be a term at all. So this one does not work. Right? Since we have started with the factors of 3 on the 9, for 9 we have 9 and 1 or 3 and 3. So let's go ahead and finish with the 3. Let's write the factors for 16. We have 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, and we have to flip them over. Right, so we can keep going with the 3's. So if we try 1 and 16, and we have minus 48n and plus 3n, which will give us a minus 45n, and doesn't work. So we keep going. And we can try 2 and 8. And we have minus 24n on the outside plus 6n. Different signs gives us minus 18n. Doesn't work. All right, so we'll go to the next one. 4 and 4, which we actually already tried, so sorry, we won't do that one again. So 3n, 3n, and we'll try 8 and 2, plus and minus. So on the outside we have minus 6n. Inside we have plus 24n. And 24 minus 6, that is not going to give 32. So we will try 3n, and we'll finish up our list with 16 and 1. And so minus 3n plus 48n will give 45n. That is not 32. So the 3 and 3 is not going to work. We will switch and try the 9 and 1. So we're going to start with our parentheses again. And we will have different signs, but we're going to use 9 and 1 this time. And these can be nasty problems. They can take a while. Right? If we try 1 and 16, when we do 16 times 9, that gets really big. That's bigger than 32. I'm not going to work it out. It's not going to work. Right? And so then we'll go to 2 and 8. 9 times 8 is 72. Plus 2n. That's still not getting down to 32. So that one doesn't work. We'll try 9n. And we'll try the 4's. Minus 36n plus 4n gives us a minus 32n. Almost works, right? And you can fix it from here. As soon as you get the right number, even if it has the wrong sign, it means you have the right combination multiplied together. But we're getting the wrong sign, so we are going to switch our signs. The sign that you had as plus needs to be minus, and the one that you had as minus needs to be plus, and it will work. Don't move anything else around. I'll write it over here just to double check. 9n minus 4 and n plus 4. And we'll check outside 36n, inside minus 4n equals 32n. Now it's positive, and this one works. So sometimes these trial and error problems take a while.